Hello, I'm Dr. Harper. This video is in operations management. It's a lecture video on the definitions. So let's bring up the notes. So in operations management can be described as the transformation of inputs to outputs. And the inputs are resources such as facilities, material, that's inventory, equipment, labor, that's people. The input then would be the products and or services, and usually products and services come together. It's hard to have a product without a service and a service without a product. Usually they're together. Now the process, I could have had a lot of things in here. I decided to put three: design operations, manage operations, control operations. The difference between these three will be important in understanding operations. Operations first, design. In designing operations, this is more than just what type of design do you need to accomplish a goal or an objective or strategy within your operations. But also it says when you have operations, you're trying to achieve something, is the design the right design to achieve those operations? Next is manage. Now the manage is day-to-day operations, planning, long-term planning, is making sure that you do achieve what you're trying to do, what you've set in front of you. Can you manage it properly to achieve what you're trying to achieve? If you can't, then there's where mismanagement comes in. Finally, control. Now control has to do with changing, often it's changing what you're doing in order to achieve your goals. Re-engineering, introducing new objectives. It's addressing new challenges. So control is being able to not just do things status quo or like they've always been done, being able to change for new challenges. But then this is just a basic input-output process, and we will see this I/O process, I/O, input-output, over and over and over again in this course. I will use this, but then change the inputs and outputs when I have different topics. But this can be expanded into functions, different industries, and different objectives. Again, this is just an overview of the introduction to the definitions within operations. First, functions. Well, this is the actions that you're doing, the actions that you're taking. You can have strategic functions or decisions or actions. You can have tactical functions or tactical decisions or actions, and detailed functions, strategies or actions. Strategic is long-term effects. Major decisions, major analysis, major functions as far as making a decision for the future. Tactical is more planning. And planning has to do a lot with the management operations. Tactical is medium term. And that is how much inventory do we make this month? How many people do we hire this year? What's our production this week? And that's planning. And we will focus on that quite a bit in this course. And toward the end of this course, we'll be looking at detailed functions or detailed operations, and that is day-to-day operations to make them efficient. And there's a lot to be done, a lot to be said, but I'll focus on some very practical, detailed operational techniques that will improve your operations. I will have a saying when I get there. It says, this is obvious. I mean, this is easy, but it's not obvious. In other words, it's, this is so easy to do. Why didn't I think of it before? It's not obvious. A lot of people don't do it. Okay, but there's different industries. I've divided it up into three: continuous industries, intermittent, and service industries. There's a lot more than this, but this is just a good introduction and overview. A continuous industry has to do with having the same operations over and over and over again. Two basic types. One is called a repetitive industry, where the units of work are discrete units of work. An example of a continuous repetitive industry would be an assembly line. You think of automobiles going down the assembly line or computers going down an assembly line. You do the very same thing on that assembly line. The other type would be a process industry, where you don't have discrete units of work. It's a continuous unit of work, such as steel manufacturing or oil refinery or different types of chemical processes. And then you have intermittent industries. Now, intermittent is continuous, but you have multiple changeovers between different continuous runs. the textile industry is a good example of this. And so you'll have a continuous repetitive industry in textiles, like making shirts, but then you stop, you have a changeover and have another continuous operation, produce coats, and then you produce socks, and then you produce pants. So each one of those is called a batch run. And there's two basic types of intermittent. One is called a batch industry, where the continuous operation is a long batch. But when those batches become very, very small, or like 1 or 2 or 5 very small batches, then that's the other type, which is called a job shop. So a batch industry is an intermittent industry and a job shop. And finally, service industry. Well, service is defined as when the customer is part of the operations, then that's an easy definition of a service industry. And we'll look at a number of different designs here in just a second, in just a minute down below. Objectives. Well, first let me just introduce operations with 3 objectives. First is monetary. Well, monetary, we'll see a lot of that in here, and that's pretty common. And that's usually where people start. Maximize profit, minimize cost. So monetary will be one objective we'll always look at. But we won't stop there. Next is time. Well, you might be able to do it, but can you do it faster and more efficiently and more effectively? And the third one is quality. Well, quality is define what quality is, and sometimes that's tricky, and we'll talk about that in the second lecture here, in another lecture. But then once you've defined it, then you want to optimize it. And quality can be a different definition for different industries and even different companies within the same industry. Now, this is a basic introduction overview to definitions in operations management. Let's go a little deeper. Let's look at operation strategy. Well, in this operation strategy, I'm still talking about definitions, but I'm defining different terms within an operation strategy. Now, I define strategy to mean a series of decisions that leads to an objective, and that objective will be a strategy. Okay, operation strategy are those decisions. Well, I'm going to look at decisions in 3 different areas. A product design decision, how you design your product. A process design decision, in other words, how you decide to make the product or conduct the service. And finally, the inventory design decision. And the inventory is how you manage your inventory. These 3 decisions together will create an operation strategy, and this will define different business strategies, different strategies within different industries, domestic and global operations, etc. Okay. First, product design. The 2 basic types of product design are customized and standardized. Well, a customized design has to do with you design the product specifically for a customer or a group of customers. You think of a custom home, a custom clothing, you think of a custom automobile, but you can also have a group of customers like a customized O-rings for NASA or for military operations, or a customized dam for the Corps of Engineers when they're building Hoover Dam. That would be customized specifically for that particular site specific. But then you have standardized. And standardized is not just one design, a design for one customer or a group of customers. It is one design for everyone. Now, standardization sometimes is required and desired. For example, the Food and Drug Administration has standards that have to be met for their food and their medications. And so standardization sometimes is required and sometimes very much desired. But also the customization and standardization can be together in the same product or in the same service. It could be customized and standardized. A good example of that is the computer industry with Dell computers. If you want to purchase a laptop and you want to, or a system, let's say a computer system, and you say, oh, well, I want to customize because I want this CPU, this monitor, this keyboard, this storage, this memory. So you can list it all. So that's customized to you. So the system itself is customized. But each one of those components is standardized. If you purchase this monitor, you want that monitor to meet all the standards. If you're purchasing this speaker, you want this speaker to satisfy all the standards. So there's an example of customized product design and standardized product design together. And how that is mixed and where it is mixed is part of your operation strategy. Next is process design. How do you go through and actually produce the product or conduct the service? Well, product and service, there's two types of designs. One is manufacturing process design for a product, or service process design for the service industry. First, let's look at manufacturing process design. There's two basic types. There's more than this, but this is just an introduction. First, you have product focused and process focused. Okay, those are the two types we'll look at initially. Well, product focused, you got to be careful. This product focused is a manufacturing process design. It is not a product design. It's a process design, but it's product focused. So be careful with the language. Well, product focus simply says that your process, how you produce this, is focusing on the needs of the product. If the product needs this, this is what I'm doing. If the product needs this, then I'm designing my process to do just that when it's needed. An example of a product-focused process design, again, is assembly line. We've already talked about that in continuous industries. In continuous industries, they'll have a product-focused process design, which is very common. Because in this assembly line, every work center is focused on what that product needs at that time. Alternatively, there's something called a process-focused manufacturing process design, where you're not focusing on the product, you're focusing on the process. An example of a process-focused manufacturing process design is a job shop. So when those batch runs are very small, you're saying, oh, I am focusing on the processes to do exactly what I need for that product, and that product could change. But I have the same process. I'm focusing on the quality of the process. So the job shop is a really good example of that. When the truck comes into the motor pool and it needs a brake job, you go to the brake department. When it needs a tune-up, it goes to the tune-up department. Universities usually are based on a process-focused design, where if you need to pay your bill, you go to the bursar's office. If you need to schedule something, you go to a registrar. Okay, and so these also can be combined. Well, in combine these in manufacturing, the combination is something called cellular manufacturing. Cellular manufacturing. Okay, and let me write it down here. Cellular. Cellular manufacturing. Okay, cellular means you create cells. And within a cell would be product focused. And so the characteristics of a product focused design is high volume, low cost, and that's what the assembly line is about. High volume, low cost. But then each cell will not produce an entire product. It might produce part of a product, maybe even a component, but it only does one operation very fast, high volume, low cost. It can do it very quickly and efficiently. Now, process focused is when you put different cells together, the way you put the cells together, you can create a product. But you can take out one cell, put in another cell, and have a little bit different product. Well, when you have different products, that's more of a process-focused process design. And so within a cell, you have product-focused, high volume, low cost. Between the cells, you have a process-focused product variety, and you can focus on the quality of a process. And so cellular manufacturing is where these two can be combined. Now, as I say, these are only two. There are many types of designs out there, but this is just an introduction to two important ones. Now let's look at service. Remember, service is when the customer is part of the service. Well, depending on how much the customer is part of the operations, will define what kind of a service operation it is. So again, I've decided to include three. Quasi-manufacturing, customer as participant, and customer as product. Well, quasi-manufacturing means the customer has very little to almost no involvement in the actual process of generating the product, generating the service. Customer as participant means they do have ownership, and customer as product is that they are not only participating, they are the product. So let's look at some example on each one of these. On these two here, a good example of these first two is fast food. You go into McDonald's or Burger King or you go into Wendy's and you purchase, you want to buy a hamburger and fries and a shake. Okay, let's say hamburger and fries. And so you say, okay, what would you like? You give your order to the person up front and you say, I want this, I want this hamburger and those fries. Okay, and they ring you up and you pay. Okay, well, that's customer as participant because the customer is participating. But that order goes to the back and then they put your order together. That's quasi-manufacturing. So the customer is part of the service because they gave the order up front, but they're not really part of the service putting it together. But they're putting it together according to what the customer said. So it's quasi-manufacturing. It's not pure manufacturing. So together, you have a service where the customer is participant up front. The customer has very little. It's quasi-manufacturing in the back. Well, the reason they separate that out is customer as participant requires certain types of skills in the server or in the service. For example, communication skills. If you've ever worked in retail and you work with the general public and you talk with them and try to get their order, sometimes it's very challenging to know what they want, what they're asking for. It's kind of like you can hear what they say, but what do they really want? Sometimes they ask for things they don't want because they say it incorrectly. And so customer as participant requires good communication skills, which requires listening. And you listen to what they mean, not just what they say. And you clarify before you go on. But on the other hand, quasi-manufacturing requires repetitive operations, being able to do the same job over and over and over again without mistakes. Now, what if that person is not very good talking with people? Keep them in the back. What if the person up front is very good with people, but they'll make a mistake every time they try to do it again? Keep them in the front. And so the skills have to be partitioned out and matched up with the service. Now, the last one is customer as product. A good example of this is the medical industry. When you go in for a procedure and you want an operation, you go into full anesthesia, you go under, you wake up, and all of a sudden, are you alive? Are you alive? Do you feel good? Was it successful? And so the customer is the product. Now, this is interesting because as an example, there's a lot could be said about this, but as an example, you can say the patient wakes up and you'll say, how do you feel? I feel fine. Well, was the surgeon good? Was the service good? Was the service high quality? And often, not always, but often the patient will say, yes, it was fantastic. The surgeon was great. Why? Well, they didn't know. They were out. They were under anesthesia, so they were sedated. They couldn't see the operation. If they did, they would know what they're looking at. Well, they're alive, yes. But how good was it? Was it good? Was it great? Was it mediocre? They don't know. But when they're asked, was the surgeon good? They say yes and said why. They'll say, they were so nice. Well, being nice is important. But being nice, does that mean that they do the procedure correctly and efficiently and high quality? Not necessarily. But then it's all part of the definition of quality because bedside manner is also important. It may not be critical because if you don't have a good surgeon and they don't do the surgery correctly, they could die. But even if they did it correctly, if they didn't do it correctly, but they did it well enough, but the bedside manner was good, then to the patient, that was a really great experience. So quality can have different spectrum. And so the definition of quality then in each one of these and skills is not just a single skill, it's multiple skills. So service is fascinating. When the customer is part of the operations, then the actual process design and services, you have a lot of skills that you have to think about and design. And the way you do that is called the service process design decision within an operation strategy. Finally, you have inventory design. Now, inventory design is how you manage your inventory. We have two different kinds here, make to stock and make to order. Well, make to stock simply says I'm going to produce my operations, my process is going to produce a product to create inventory, and then demand is met out of inventory. Make to stock. A good example of that is going into a grocery store, buying a loaf of bread, and you go to the bread department, you have all these loaves of bread, that's inventory, and you're buying it out of the inventory. Well, the bakery bakes it not to satisfy the demand directly, they bake it to create inventory. And then the inventory satisfies the demand. That's a make-to-stock operation. Now, make-to-order operation is you don't produce the product to create inventory, you produce the product to satisfy an order. So a deli is an example of that. You go in and you want to order a sandwich, and you say, I want a sandwich, so what do you want on it? And you tell them exactly what you want. And then they will make that one sandwich specifically for you. And so the production process is making it to the order. Okay? And a lot of construction is design build. I'm building this building specifically for the client's wishes. I'm designing it for them. Okay? And these also can be combined, a make to stock and make to order. But the make to stock and make to order can be combined, not necessarily combined, but also you can have a boundary between the two. And so the make to stock operation, inventory design, is really referred to as a push system. And the make to order is really referred to as a pull system. Okay, a push system says I'm making the product to create inventory, I'm pushing it toward the customer. The pull system is that order is pulling the product out of operations. But then you'll have a push system coming down, and then you'll have a pull system. And that push-pull then, the boundary of the push-pull could be an actual operation strategy decision within inventory design. For example, you're going to buy a laptop. You go into a store, let's say Best Buy, and you say, I want to buy this laptop, this Hewlett-Packard laptop or a compact or something, and say, oh, okay, well, we have the Lenovo. Okay, here they are. This is what we have available in our inventory. Oh, let's make to stock. Okay, if you want this, we'll help you. Fine. If it's not here, we can order it. Oh, okay. Well, everything I have here, I don't want. I want something very specific. Bing, 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 bing. Well, that store all of a sudden shifts from a make to stock to a make to order. Well, Michael Dell comes along with Dell Computers and says, wait a minute. Instead of having the push system goes all the way to the retail store. But then what happens if you say, well, let's call Dell and actually tell them what you want. They'll assemble it, and then they'll ship it to you. And so it's not a make to order, it's an assemble to order. And so this push-pull boundary then goes deeper into the supply chain. So there's still a push part, and that push is not on the products. The push is to create inventory of components. And then those components are put together to create the product to be shipped. So the push-pull boundary is not in the retail store for the product. The push-pull boundary is upstream to the components. And so the components is a push system. The system is a pull system. So that design of your inventory then is part of a decision within your operation strategy. Now, hopefully you can start seeing how these things work together. So if you have a make to order, then that probably can match up very easily with a process-focused process design, which is a customized product design. So these things can match up, and historically they have. But technology has begun to blur these boundaries such that you can have characteristics from all these different strategies, these characteristics because of technology. And that's why years ago, decades ago, operation strategy became much more important to create a strategy within an organization and even within an industry. And so this is an introduction to what we will be looking at in this course. Okay, the last thing I'm going to cover, this is the definitions. Next is going to be problem-solving processes. And I'm going to look at the break-even analysis as just one technique, but an important technique, one of the first techniques I'm looking at in this course, because the break-even concept, this concept of break-even, we'll be using over and over again throughout the course. So I want to introduce it here, this version of it, with this simple example from what we just talked about, and also revisit this again with other topics. Okay, here's the problem. 3 production processes. An automated, that's like a product focus up here. That's like a product focused. Okay. And then cellular, that's a combination of product focus and process focused. And job shop, that's a process focus, have the following cost structure. Which process is preferred, meaning has the lowest cost? Well, suppose we had this information. Here are the 3 processes. The fixed cost here is $110,000 per year, $80,000, $75,000. The variable cost is 2, 4, and 5 per unit produced, because each of these will produce a unit. That's how much it costs to produce a unit. Now, I'm simplifying this just to illustrate break-even analysis, but this form of break-even analysis is extremely common. Okay, now these numbers aren't exactly in magnitude correct, but orderly, the order in which these are placed are relatively correct. In other words, automated usually is much more expensive to set up and operate, but the variable cost is high volume, low cost, and the low cost is the variable cost. Cellular job shop is cheaper to set up, but it's more expensive to produce a unit. And cellular is pretty much in the middle. Now, this isn't true for all industries, and it could change, but let's just use that for now. And let's say, let's use this to introduce break-even analysis. Okay, so then you say, which one is the cheapest? Well, it depends on how many units you're going to produce. How many are we going to produce? Don't know. Good point. But then how would we go about a break-even analysis then? Okay, well, first of all, before we work this problem, I want to point something in the problem-solving process, and that is the definition. I have told you this is a break-even analysis. Is it or is it not? How do you know this is that type of break-even problem? Good question. The first part of solving a problem is understanding what the problem is. You can't just say it's break-even, because sometimes it is and sometimes it's not. How do we know? How do we define this and know that this is a break-even problem to do a break-even analysis? Well, let me show you 2 ways to do that, and both are important in this course. The first way, I call it the boundary value approach. 1, what if the production on one boundary is extremely small? What if we produce 0? Now, we're never going to do that, but just an extreme value. If we produce nothing, and these variable costs here then really don't apply because we're not producing anything, which one has the lowest cost? Well, obviously, the lowest cost here is the job shop. So what that really implies is that if we do have variable cost, very low production, job shop is going to be the cheapest. It's going to be the lowest cost. And that's why the lower volume you move to job shop and process focused. The other end of the spectrum, the other extreme value, what if we have produce a lot, like 1 million units up here? Okay, so up here, this $2 over a year, this is really $2 million, 4 million, 5 million, and it's 2,110,000, 4,080,000, 2,110,000, 4,080,000, 5. Now which one's the cheapest? Well, the cheapest one is going to be the automated. So if we have a high volume to get a low cost, we move to automated, which is an assembly line as an example, which is product focused. And so since very low cost, very low production is job shop, very high production is automated, then the production between 0 and 1 million in there somewhere, these costs are going to come together here eventually. And that is break even. So it does exist. And so we know that there is a break even production amount such that these costs are going to be the same. That's the first way. The second way is the structure of the problem. And we'll be using this in some of the problems. The structure, when the fixed cost decreases 110, 80, 75, at the same time the variable cost increases 2, 4, 5, when one goes down, when the other goes up, then that right there illustrates that there's got to be a break even in there somewhere. So this system does define a break even problem. For example, what if we took this 2 and put it down here? We took this 5 and put it up here. Now, the fixed cost decreases and the variable cost decreases. Is this a break-even problem? No. Okay, then which one always is the lowest cost? The job shop is always the lowest cost. Always, no matter what you're producing. And so in this case, I have the same structure, I have numbers, but the numbers have a structure, I have the same format. I have a structure, but the structure is not the structure for a break-even. This is not a break-even problem because the numbers don't bear that out. They don't define it. Now, if I bring those back, boom, boom, that is a break-even analysis. There is a break-even. That is a break-even problem, and there is a break-even solution. So once you've defined that it's there, it exists, it's the kind of problem it is, second is you go and find that answer. Again, there's 2 ways to approach the solution. Okay, before I get to this solution here, one way is down here, and this is the actual mathematics. But before you get to the mathematics, there's another way, and that is the logic. Look at the logic of the problem. Understand the problem before you start working the problem. For example, let's look at the bottom 2 here. Well, the fixed cost decreases while the variable cost increases, so does the break-even. Well, what is the break-even between those two? Well, let's look at the extreme value again. If I produce nothing over here, the difference here is, let's see, 80, 75 is $5,000. Okay. Now, when I start producing items on either cellular or job shop, then I'm saving $1 for each unit I produce. That's true. Well, how many can I produce to where that production savings will equal the increased fixed cost of 5,000? Well, dollar per unit will be 5,000 units. So 5,000, a production of 5,000 units would be the break-even between these two. Because 4 times 5 is 20, plus 80 is 100. 5 times 5 is 25, plus 75 is 100. So at 5,000, the cost of those is the same. So that cost, so the 5,000 is the break-even production. So I pretty much know what that is. Now, I made these numbers where they're exact. In practice, it's not going to be exact, but you get a feel. It's around 4, 5, 6,000. It's not 100,000. It's not 5. It's somewhere in that range. You get a feel for what the answer is. What about automated and cellular? Well, the savings is $2. The difference is, what is this, 30,000? So 30,000 over 2 is like 15,000. So the break-even here is 5,000 here between these two, 15 between these two. Somewhere between 5 and 15, that's pretty much what the answer should be. You get, here it comes, you get a feel for what the answer is. And a lot of people say, this sounds crazy. It's not. When you work these problems over and over again in a job, an industry, then you get a feel for what the answer should look like. But then you want to validate that feeling with arithmetic and mathematics. So you come down here, and this is how you do the solution mathematically. Let X be the annual production. And so X times the variable cost plus the fixed cost for A and C here, well, I bring down the 110 and 2 right here. I bring the 80 and 4 over here. Whoops, I left out the X. I solve for X, and there I get the break even. Okay, 15,000. Does that feel right? Yeah, that's pretty much what we had before. Okay, what about C and J? Okay, I bring down the 80 and 4 times X, 75 and 5 times X. Again, I left off the X. I got to change that. I've changed it on the notes that I'm giving you. Solve for X and 5,000. So it's 5,000 and 15,000. Does that feel right? Yeah, feels right. So you have the arithmetic or the mathematics to validate the feeling, and the feeling makes you comfortable with the arithmetic and mathematics. They have to go together, because if there's a disjoint there, maybe your feelings was wrong if the math is right. And so you go back and say, what am I seeing wrong? Let's learn from this. But if the feeling is right and the math is wrong, you could have made a math error. Happens all the time. So both of those go together in industry. Okay, and they don't talk about that too much in school, but in industry, you get a feel for what's right and wrong. If it's not, you research it out to see, why did you feel that way? Okay, and sometimes the arithmetic, the math, can teach you concepts, and sometimes the feelings can correct your math. Well, that's the definition, solution, and finally presentation. Okay, now the presentation here, I'm using graphics. I'm using a graph to present this. So here I have a graph. Down here's my annual production. Here's my cost over here. And so if my annual production is 0 over here, again, if it's 0, then my cost is just my fixed cost, 75, 80, 110. So I come down here. If my production is 0, this is 75, there's 80, and there's 110. Now, when I start producing, I'm going to add $2, $4, and $5 for every unit I produce for these processes. So for the automated, the dashed here, this is a $2 slope. Okay, cellular is a $4 slope, a little bit more. Job shop here, the dot is a $5 slope, and notice the slope is getting larger because the cost is greater per unit. The variable cost is greater. Well, since this is lower and this, okay, you can see here where these two cross right there, that's 5,000, that's the break even. Well, the automated and cellular here, these two cross right here, and that's 15,000, that's the break even. But notice automated and cellular here cross up here. Well, cellular will always be cheaper, will always be lower cost. So graphically, you not only illustrate the answers, but you illustrate all of the possible scenarios around those answers. And so it's much more informative to get a feel, again, for what the problem is. This is how sensitive the problem is. Okay, look at job shop. Job shop and cellular is very close, but automated for low production is a lot costlier. Okay, but up here, the automated and cellular is fairly close, but the job shop is a little bit more. Not as costly here, but it's a little bit more. And that's why people like cellular. It's because it's kind of in the middle. You can go back and forth. But the point is, this gives you insight, not just the answers, but insight on how to present it, because having the answer doesn't help anyone if you can't communicate it well. And the communication and presentation is key. And notice in the syllabus, I said recognition of the problems, application of the techniques, and communication of the results. And here they are. Okay? And so these three illustrate problem solving in industry. Not necessarily in school, but in industry. And this is operations, and this is what you have to do when you get out there. So let's get back to the original question. Which process is preferred here, automated, cellular, or job shop? Well, it depends on the production. We said that at the very beginning. But now that we understand the system, we understand production and costs and the variable costs and fixed costs, we understand it here, then we can ask the question, let's forecast what our annual production is. Well, in forecasting our annual production, that's a different analysis. This is the break-even analysis to understand what we're going to do if we know our production, but then we can have a forecast analysis of our production, and that analysis would feed in then to the break-even analysis. So in operations, it's not just one analysis. It's multiple analyses going together to create, again, a decision, which is part of a strategy. And once you have a strategy, make sure your decisions align with that strategy. So that's all I have for this. So that's all I have for the definitions and the introduction to this course. We're going to have a lot more, but this is a beginning. It shows the definitions, it shows the problem-solving approach, and we'll be putting these together as we go through with the input-output model. That's all I have for today, and we'll see you later. Take care.